डेटा स्ट्रक्चर। लीनियर डेटा स्ट्रक्चर के अंदर आता है एरे, स्टैक, क्यू, लिंक लिस्ट। नॉन लीनियर के अंदर आता है ग्राफ एंड ट्री। नॉन प्रिमिटिव डेटा स्ट्रक्चर में आता है एरे, linked list where each element point to a next pointer in the next sequence. Can't be implemented a stack and queue DQ. Fast node, node, null. Helps to insert and updation. We cannot add extra in finding. Evaluation post-week expression comes under stack. Process of accessing data stored in a select adjacent memory in similar is to manipulate. Note, all insertion takes place at top. LIFO, last in first come, last in first out. Push pop, okay, top equal to minus one empty, top equal to size minus 1 equal to full. Recursive produces to implement using stack. Overflow, when you insert in a full stack empty underflow. Convert recursion to iteration. Check whether arithmetic expression has balanced parentheses. Types of a stack: register stack, memory stack. Register stacks handle a small amount data with limit height. Memory stack handle large data with flexible height. A stack is not suitable for BFS and process scheduling. Application of a stack: backtracking, recursion, string reversal, undo, redo, DFS, backtracking, expression conversion, tower of Hanoi, syntax passing, undo, redo operation. Next is queue, FIFO and LILO. Front, that is delete, DQ. Rear, that is insert, NQ. FIFO, first in, first out. Waitless, asynchronous, transfer, insertion, happen, insertion. Rear, deletion, front. Okay, insertion is happening from rear and deletion happening from front, that is DQ. Okay. F equal to R equal to minus 1 empty, R equal to size minus 1 full. Tree traversal uses a queue level order. Okay. Primitive data structure: int, char, float, double, and pointer hold single value. Non-primitive derived elements: linear data structure, array, stack, queue, linked list. Non-linear tree and graph. Linked list, not application is random access element. Okay. Memory allocated dynamically at runtime. Each element point to next in operation sequence. First node 5, that is node, last node, tail node. Help to insert and updation. We cannot add extra in finding. Operations on data structure: accessing, searching, sorting, insertion, deletion, updation. Arrays, a linear data structure. A string element continuous in memory access by index. Fixed size at creation. Zero index in language, clip, C++, Java. Constant time access, order of 1. Expensive insertion and deletion operation. Multi-dimensional array, by default value store row major order. Linked list, not suitable for binary search. Polynomial additions is implementing. More efficient in double linked list compared to single list. Delete last node. Operations: insert, delete, concatenate, rearrange, substring, linked list. Doubly linked list, minimum number of fields in each node equal to 3. Nodes contain data pointer to the previous node and pointer to the next node. Traversal is bidirectional. Operations easy with backward traversal. Each node has only one pointer to traverse to the list back from. Efficient deletion of the node pointer is known as quick insertion to before given node. To insert a node in a circular list, at rear position inserted as fronted position. Circular linked list by using two pointers at a different speed. Application of queue, order linear data structure, resource management, printer, disk, CPU, data transfer, asynchronous transfer, pipes, files, and pips, files, and I/O sockets, buffering, media plays, playlist, OS, handling interruption, CPU scheduling, traffic system, traffic light control, algorithm, BFS, printing, document queue, ring buffer, also called circular queue, array to implement a queue, fixed size, and possible overflow. Application of circular queue. Memory management utilize unused memory in ordinary queue. Traffic system cyclic control of traffic lights. CPU schedule manage process ready to execute or waiting evacuate if every priority queue in and max heaps does not follow FIFO. Application of priority queue. CPU scheduling graph algorithm etc. primes. Stack implementation Huffman coding. Event driven simulation finding the largest and smallest element. DQ. DQ. Double-ended queue. Linear data structure where insertion and deletion possible both ends. Does not follow FIFO. Support both stack and queue operation. Applications act as both stack and queue. Palindrome checker. Job scheduling algorithm. A stack implement of queues. We can implement queue using two stack. Queue implement of stack. We can implement a stack using two queue. Highest time complexity of dynamic array when array need to resize inserting element at the beginning. Disadvantage of using array of implementing a stack data structure. Array have a fixed size. Only non-zero element of these positions. Min and max heaps priority queue implementation. B-trees file system implementation. Arrays expensive insertion and deletion operation. Graphs electronic circuit design analysis. First about B-tree of order M. Leaves nodes are not same level. LL and RR. Available trees known as single base rotation. Stack full T. Convert infix to prefix stack. DQ insertion only rear and deletion at front input restricted queue. Queue implement using a stack to stack circular queue. Job scheduling priority highest always at the front. Data type in Python. None, list, set, tuple, dictionary. Data type considered as a number in Python, int, boolean, complex, floating point. Operator is check if both operand referring to the same object is not immutable, NST. Not immutable, SD. Set dictionary, mutable, string, tuple, ST. Yield data type not a non-primitive data type floating point. Lower precedence and start and end oval. Arrows connector. Input output parallelogram. Process rectangle. Decision diamonds. Recursive algorithm uses DFS, create a shortcode. Recursive structure. Backtracking uses DFS with bounding. Trial and error also following backtracking. Optimization problem also following backtracking. Hashing algorithm. Convert data into fixed size hash value, enabling rapid data access retrieval in hash table. Commonly used in database or parcel storage. Divide and conquer. Recurrence relation T into N, T n divided by 1 plus 1. Binary search uses divide conquer. Recursively solving subproblem divide and conquer. Quicksort also follows divide and conquer. Stressens matrix multiplication also follows divide and conquer. Dikshitra algorithm follows divide and conquer. Next, greedy algorithm. Dikshitra shortest path algorithm follows greedy algorithm. Minimum spanning tree, greedy algorithm. Optimal choices at each step to find a global optimum, greedy algorithm. Optimal solution at every step without considering future, greedy algorithm. Dynamic programming algorithm. Longest common sequence follows dynamic programming. Dikshitra algorithm follow dynamic algorithm. Fibonacci series dynamic programming algorithm. Optimal solution comprises optimal solution. It uses subproblem dynamic program. Dikshitra algorithm follows dynamic programming. Greedy approach Dikshitra algorithm. Shortest path in a graph with non-negative edge weights, that is follows Dikshitra. Shortest path from single source to all node is Dikshitra. Single source shortest path Dikshitra. Selection sort known for simplicity but it is inefficient for large data set. Bellman Ford works on dynamic programming, finds the shortest path between given source and every vertex graph with weight and non-weighted works with a graph of negative Bellman. Not a negative weight cycle Bellman. Does not work with continuous negative weight cycle Bellman. 0-1 knapsack problem dynamic programming greedy not a solve using greedy approach knapsack problem knapsack using greedy algorithm. A star algorithm pathfinding on graphs GAPS uses a heuristic to guide the search. Floyd Warshall algorithm. Dynamic algorithm also follows. Johnson algorithm follows. All pair shortest path algorithm. Finding shortest path between all pairs of nodes in weighted graph. That is Floyd Warshall. Routing problem in communication network. O star B star B star B star B. BF working with DP. Kruskal algorithm primes used for same below. Used minimum spanning tree. Kruskal. Minimize total edge weight. Kruskal. Primes a lot of Kruskal. DFS searches. Single source shortest path. Unweighted graph. Use greedy algorithm. Works on Q graph shortest path by traverser or node from same level. DFS works on stack. Exploring path from root node level to search a cyclic graph. Most efficient to find whether a cycle is present is in general graph DFS. 8 queens problem backtracking construct staticals not a complete problem shortest path algorithm. Hamilton problem graph theory path is a graph to visit every vertex exactly once. Return a starting vertex. Hamilton problem NP complete problem. NP hard problem. To solve this problem, it do not have to be in NP. Time is unknown is in NP hard problem, not a decision problem. NP hard problem. Not not all NP hard problem are NP complete problem. P equal to not NP which is incomplete. Non-deterministic NP complete. Turing machine NP complete. It is fixed in NP hard NP complete. Exclusively decision problem NP complete. All NP complete is NP hard. Decision greedy find use. Dikshitra shortest path greedy. Travel salesman problem dynamic programming solved with branch and bound technique. N-queens problem and 4-queens problem backtracking algorithm. Insertion sort for sorted array. Quick sort divide and conquer partition and exchange sort. Internal not a stable quick sort not is suitable for linked list. Selection sort n square time complexity. unstable but in place. Least number of swaps. Sort divides the array into sorted and unsorted sublist. Heap sort, not a stable priority queue. Internal heap data structures used cannot sort in numbers in order of n comparison. Bubble sort, stable sort, n into n minus 1 divided by 2. Adjacent element are compared and swapped. Binary search, n divided by 2 plus k, abelian or red black tree. Merge sort, decrease variable factor approach involve reducing. Does not have worst case complexity order of n square. Divide and conquer, efficient for sorting large data set. Merge sort, handle duplicate stable. Merge sort, sort algorithm has execution time that is least dependent on initial sorting, also uses recursion. Least worst time complexity. Merge sort, hill climb algo, local optimization algo. Hashing, fastest technique to search for an element. Perfect hash table. Hashing, a stepwise refinement technique of gradually working from a high level to detail algorithm. Prime's algorithm for finding minimum spanning tree. Greedy. Tower of disk. Okay. A union goes to user defined data type. Function goes to subroutine. Interactive environment goes to virtual reality output device shadow mask. Infix used for writing express in which binary operators are written between operands. Radix sort algorithm best case complexity of omega and k. Algorithm linear search both is sorted and unsorted. Array binary search only sorted. Has stable collision. Binary tree used in Huckman full binary tree. Shortest job first scheduling algorithm minimum heap. Dataset has order of n log time complexity external static trade-off. Example of space-time trade-off. Memorization of repeated computations. Merge the bodies of two nodes, loop jamming, a stable algorithm, bubble sort, insertion, sort, cell sort, merge sort. That is stable. Stable means come as SBIM, a stable. Algorithm used for reinforcement machine Q learning. Not an NP complete problem, such as path problem. Backtracking uses depth first node generation with bounding function. The count to infinity problem is associated with distance vector routing algorithm. Dikshitra shortest path greedy design. Fluid version dynamic programming. Kruskal greedy design. Merge sort divide and conquer. Minimum and max priority queue implementation. B-tree file system implementation. Array expensive insertion release. Graph electronic circuit design. Greedy minimum weight spanning tree. DFS connected components. Dynamic programming all pair shortest path. GD equal to GDD. Station matrix divide and conquer. Insertion sort decrease and conquer. Grassy feminist financial transform and conquer. Fluid shortest path algorithm DP dynamic program. Heuristic search algorithm they can handle complex and dynamic search. Hashing and collision. Node with collision resolution folding. Hashing collision reusable when an attempt is made to insert a record at fully primary bucket. Scheduling algorithm most suitable time sharing round robin. Balance factor of a node in ABL tree. Height left, height right. Sorting algorithm have a time complexity of n square. Bubble sort, selection sort, insertion sort. ये देख लो linear algorithm है linear sequence का order of 1 order of n order of n order of 1 most efficiently find whether cycle in present graph dfx find shortest path in a weighted graph Dixitra algorithm dynamic programming Kruskal algorithm also Prime's algorithm finding minimum spanning tree of graph Johnson algorithm reference answer okay Let us give a question. Fine.